So let's get started with the first notebook. This one is actually about Marimo itself, which is a new notebook inspired by the Jupyter and Observable notebooks. Not only does Marimo address the shortcomings of Jupyter, it also has a ton of features such as UI elements, a reactive execution models, the ability to create your own UI elements or custom visualizations. It has great AI support, and that includes both a sidebar assistant and also the ability to create your own custom AI chatbots. It has support for connecting to multiple data sources like Snowflake, Postgres, DuckDB, and Databricks. So these notebooks are fairly self-contained, and you can just read through it if you prefer to consume material in that way. But in order to demonstrate some of the core features of Marimo, I think it's easier to just create a fresh notebook like this. Let's call it example notebook 1, something like this. And then I start by importing the Marimo library. So the first concept I want to explain is Marimo's reactive execution model, which I believe is inspired by the Observable notebook. Now, how this works is that if you define a variable like this, so you have a name x equals 10 in one cell, and then you refer to that name in another cell, then behind the scenes, Marimo will create a dependency between this cell and this cell. And in practice, this means that if you update this cell, so redefine it to be 15 and you just execute this cell, by default, every cell that uses or refers to this name here is then marked as stale. It needs to be reevaluated. So this re-execution happens by default, as you can see here. When a cell change, all the dependent cells are re-executed. If I disable this and I again update this value to 17, I execute this, you can see that this cell becomes yellow. It is stale and needs to be rerun because the X value has changed. So this concept of dependent cells becomes really clear if you click here on the left hand side on the Explore Dependencies tab here. And then you have cell 1 and cell 2. If you click on cell 1, you see this edge between these two nodes. What this means is that cell 2 is a dependent cell of cell 1. So whenever cell 1 changes, cell 2 becomes stale and needs to be executed. If we introduce a additional variable like this, which is 10 plus x, you see that a new cell has been added here, cell 3, which is also dependent on cell 1, and we can add yet another one, y equals c plus x. So here you can see, if we click on this, that there's actually two connections, because cell 4 is now dependent both on cell 3 and on cell 1, and cell 3 is also dependent on cell 1. So there's this dependency network that Marimo handles for us. So we can also view this. Another means to explore this is via the vertical tree tab here. This gives you a tree structure that you can zoom in and out on to view the dependencies. So here it becomes really clear that cell 1 is a type of root in this computation, and that this is connected to cell 3, and cell 3 is also a parent of cell 4. Cell 2 is a child of cell 1, and then you see this also implicit relationship between cell 4 and cell 1 via cell 3. It's this cell dependency graph coupled with the ability to automatically rerun stale cells that gives us the reactive execution model of Marimo. Now, what this gives us is a way of building rich user interfaces. So to demonstrate this, let's us create a slider component using one of the built-in Marimo widgets. So let's do this, 1 stop equals 10. And then Marimo will just render this as a HTML JavaScript component. The point here is that because we have this reactive execution model, if I access the currently selected value of the slider via its value attribute like this, You can see as I change this slider by sliding it up and down, the value attribute changes, and every cell that refers to this attribute value will automatically be re-executed. So let's just explore this in the dependency graph again. Let's just zoom in here. We can see we have cell 6. Then we can create another cell equals slider value plus x. You can see here that this cell 7 is dependent on cell 5 and on cell 1. So if I change this, it will rerun. If I change this, just the cells that depend on the slider value attribute will rerun. You can use these UI opponents like the slider, a button, or a text form directly in your notebook just to enhance the user experience. But Marimo also comes with this app mode, which you can preview by clicking here. Now, how this works is that it allows you to view just the output cells of the notebook and deploy that as a web application. And we will explore this in some of the other notebooks, but to demonstrate how you can use this to create a dashboard or some sort of website based on the contents of a notebook, we can look at the grid layout here. So here you can choose how to render the cell outputs of your deployed web application. So in this case, let's just make something simple here. Here I have the slider element on the left hand side, and then I have the output here. So if I just do this, you can see how it would look as a web application. And here you can imagine building something way more complicated that has a bunch of buttons, it has tabs, it does some computation, it accesses data either inside a notebook or gets it from an external source. The point is basically that the reactive execution model makes this possible. If you jump back to the companion notebook, you can see there's an example here of using a drop-down UI widget, which lets you select one of 3 volatility plugin values. And you can see that the value attribute will reflect the currently selected plugin. Now we want you to have a look at exercise 1, which is about playing with the text input and getting some hands-on experience with working with the reactive execution model. There are some cells here that we want you to fill in, and then if you get stuck, you can look at the solution by clicking here. In exercise 1, we want you to get some hands-on experiments with the UI elements. So play around with the text component, and if you're stuck or want to reveal the solution, you have to click this button. So let's look at some additional features of Marimo. Down here you can see some buttons. If you click the one labeled Markdown, you will create a new Markdown cell, and what you enter into the cell will be rendered as Markdown. So what's actually going on under the hood here? Well, if you click this button, you will see that the contents of the cell is just a string. So it's just a Python string that is passed to this function MD of the Marimo library. And then you can see there are some checkboxes here, R for raw strings and F for F strings. So if I enable this, an F will be added here. So if I make this multi-line for it to be easier to see, I can actually use string interpolation. So I can pass in the X value that I defined above, like so. And you can see that it's rendered. And you can do like X plus slider dot value. You're still operating with the reactive execution model of Marimo. As you can see here, if you select this cell, there is a dependency here between the definition of slider, like this, and the markdown cell. So that means that as you slide this up and down, the slider.value attribute changes, which marks this cell as being stale. And if the auto run is enabled, the cell will be automatically executed. So you can use these markdown cells also to build your data application. These markdown cells are actually very powerful. You can pass in HTML like this. So you can see here I have a bold tag and it will be rendered as bold. You can insert images, media, LaTeX, and so on. If you go back to the companion notebook and scroll to the top, you can see that this initial set of instructions, if you reveal this, look at the code, you can see that this is actually HTML tags where we center the image, and then it's just plain markdown. If you scroll down here by using the navigation tool to the markdown section, you can read some additional information here about how this works. But what I want to highlight is this cell here, which showcases some of the capabilities of the markdown function. So if you click here again, you can see that we're using some HTML, we are using some string interpolation with some Python expressions, we are using LaTeX, and again more HTML. There's a lot of things you can do with this. At this point, we want to get some actual data into the system. So let's go back to the example notebook and go here to look at the database connection. So Marimo has built-in support for multiple databases. You have familiar ones like MySQL, SQLite, Snowflake, and BigQuery. And then the default one is actually DuckDB. So a hand-wavy explanation of DuckDB is that it's a single process SQLite for analytics query engine. So it's not meant for doing transactions, for inserting and deleting data. It's meant for doing statistics like multiple joins, heavy compute. So Marimo has built-in integration for this. So this is the default query engine. So if you click on creating a SQL query like this, you see that it will use the default DuckDB in-memory instance. So if we don't have any tables loaded yet, but let's just do a query like this and execute it. You can see that, okay, it does the computation. It creates a row containing a single value. Now, what we actually want to do is, if we get rid of this, is to, let's say we create a new cell, and I've copy pasted in a query here. So what's going on is that we, as in the introduction, we are running volatility plugins using the Parquet renderer to write the output to a file. So now we can use the read Parquet function from DuckDB to read these plugin output files as tables. So let's see how this looks. In this case, we are just calling read Parquet for the PS list Parquet file, doing a select statement, and just returning the first 10 rows. So here you can see what happened is that we executed a query which returned a set of records, and then Marimo rendered it using its built-in table mechanism. So at this point, we need to get back to the volatility and memory forensics world. So here comes the trick. In the latest version of volatility, there is a Parquet renderer. So what that means is that if you run a particular plugin and you choose to render the output using the Parquet format, you can write that to a file, and then what you want to do now is to read that output as a DuckDB table. So here you can see an example of running volatility for this particular memory dump using the Parquet renderer, using the PS list Windows plugin, and redirecting the output to this Parquet file. So let's create a new cell, and I'll just copy paste in some data. So let's break this query down. So here we are calling the read Parquet method to read this Parquet file from disk. And then we do a select statement from the entries that creates, and then we do a limit just to return the first 10 entries. Now, if you execute this, so remember, this is DuckDB reading the Parquet file containing the output from the volatility plugin, doing a select operation, and returning 10 records. Boom. So what happens here is that it does the query, returns the results, and then Marimo uses its built-in table component to display it. In this case, it's just 10 rows, but here we already see the potential of using the notebook instead of operating directly on the command line. So let's say we do let's remove the limit clause here. Okay, so in this case, the full data set. And I should just highlight one feature here is that if you specify this output variable here, what this means is that if I write this as processes, and then you can click view as Python. Similar to the markdown example is that we are just using the SQL methods from the Marimo library, and then you're passing in the SQL query, and then you're returning the result of the SQL function to the variable called processes. Now, what the processes contains, what type of format it can be configured here. So it can be the native format, which in this case would be a DuckDB relation. It can be converted to polars or to pandas. So if we execute this, and then we can just look at what the automatic output format is. Processes. So it's a polars data frame, and you can see also that Marimo automatically uses the same table component to render a data frame. Now, what we want to do next is actually to create a table out of this. So let's just go up in our companion notebook, which contains all this information. Copy paste this in. Let's also restore this as processes. Okay, so previously we just did a query on, we first read the Parquet, the contents of the Parquet file, and then we did the SQL statement on the result. What we want to do now is actually to create a table out of it inside our DuckDB in-memory instance. So again, we are reading the Parquet file using the readParquet function, and then we're calling the create or replace table statement. So we're creating a new table called process lists from this statement. So we don't need to do this. We can do like so. If we execute this, great. You can see it can seem like nothing happens, but if you look on the explore data sources here to the left hand side, here you can see all the tables contained in our default database connection, which is this in-memory DuckDB instance. And you can drill down and you can see, hey, we actually have a process list table now, and it has these columns. Right, and then if you click on the columns, you can see some statistics. Now, okay, let's convert this to a SQL cell as well. And now we do select all from process lists. Then you can see that we're actually referring to this table that we created. And now we can use this as the output again, like process. We can create a more complicated query where image file name equals command.exe. You can see that we did some filtering here. Another option here is to format the cell like so to make it more readable. Again, the output is written to this proc variable, which is a polars data frame. You can see, here we go. And now on the left hand side again, I want to show that you have the contents of the table, the DuckDB database, all the tables, and then you also have the Python data frames shown here. So this is a polars data frame, but you can see here that you have an overview of all the columns, and in this case it's just command.exe because that's what we filtered for. But that's also accessible here. So if you don't want to work with DuckDB or Snowflake or whatever, just work directly with something like polars or pandas, it will also show up here. Now I want you to go back to the companion notebook and try your hand at writing some SQL queries. So here we're actually doing operations on the output of volatility. So we are doing forensics here. I should say before you do exercise 2 and 3, which is about writing these SQL queries, if you don't like SQL, it's not your thing, then don't worry about it. You can just skip ahead or look at the solution, because in the remainder of the workshop, we will actually be using a data frame API similar to polars and pandas. So you can try if you want to, otherwise don't worry about it. Marimo has great support for multiple visualization and plotting libraries, but especially Altair and Plotly are the two ones that have the best integration, because they can take advantage of the reactive execution model. So in practice, this means that you can make visualizations where you can interactively select something, like select part of a bar plot, and that selection will be propagated back to Marimo. So we can use that as sort of the similar to the slider.value. You can propagate that back to Marimo and then continue to work on what you have just selected. Okay, so let's demonstrate how to use Altair. Here I created a new SQL cell where I just do a selection, have a selection statement, and I use the specify to send the data to an output variable, so I get a polars data frame. So let's just execute this. Now, if I just rendered, let's see if I can type this correctly, processes like so. Okay, so I have a polars data frame, and if I click here, I can enter the chart builder. So here, and I click this little plus sign. So now you get this interactive chart builder, which lets you construct visualizations in using this interface. For example, you can do like a line chart, bar chart, pie chart, and so on. In this case, let's try to create a visualization of the process creation event. So on the x-axis, I want to use the create time value, so the create time column, which is temporal. I want the granularity to be seconds. And then on the y-axis, I just want to have the counts. Let's see what happens here. So this is the bar chart of all the process creation events. So you can see at this particular second, there was certain amount of processes that were created, and then you can continue to modify this. So you can do faceting. Like for example, if you want to have one visualization per row per let's say image file name. If I click on this, it'll take some time, but you can see that I get one visualization for this process or this image file name, and you can see there's not much happening here. But if you go down to something more interesting, yeah, here we go. For example, here you can see tradingview.ex. At this point, for this second, there was one event created, and then here there was 3 processes created with that image file name, and so on. Let's just get rid of that, and then you can just configure the tooltips, and you can go up here to add some styling. For example, to add a title to your plot, let's call it just processes. No need to be too creative here. And similar with the x-axis and y-axis, you can tweak it a little bit and add some labels, choose color schemes, and you can actually continue as well to create multiple visualizations with other charts. But okay, so the key here is if you click on this Python code, here you will actually get the corresponding Altair code for creating this chart. So Altair is a declarative visualization library. We're not going to go into much detail about that, but if you click here on the plus sign, you copy this code to your notebook, and then you just have to change this, like the input for the Altair chart. And then also you have to import import the Altair library. Import Altair as alt, and then you can let's see. Oh yeah, I've already it already generated the import statement there. But okay, let's do this, and there you have it. You see, this is just Python code, and here you have this interactive JavaScript visualization where you have the tooltip. As you can see, you can configure the tooltip here, and you can configure the properties like the title and so on here. Now, back in the companion notebook, we have included another visualization. This one creates a display of the top K most common DLLs. So which DLLs were most frequently loaded by all the processes in the system. So the way we do this is we have the query that uses the output from the DLL list volatility plugin to compute the K most common DLLs, like it does a count operation. And the way it works is that the K value is fed in just by using string interpolation. This is an SF string where the K dot value is actually created here by this slider. So as you slide this up and down, it updates the K dot value, and this query reruns, and it stores the output using the DLL's data frame. So then what happens is that this Altair code that generates this plot is re-executed whenever you change the K value as. Then the query is re-executed. So let's just see how it works. If we do slide it all the way down to 17 to 10, you see like the 10 most common common DLLs is, not surprisingly, NTDLL. It's 169 processes that use this module. And then if we continue all the way down, like see, it's like 50. We have chosen this to be the most, the highest K value. Then we can scroll down. You can see that only 37 of the processes in the memory dump loaded the Win HTTP DLL. And here you can see the Altair code. There's nothing special about this. Another super important part of Marimo is the built-in AA capabilities. So let's go back to the example notebook to demonstrate. So if you go on the left-hand side, you see you have this chat with AI button. So if you click this, it will, the sidebar AI assistant will pop out. So this is an AI chat interface, but what sets it apart from using like ChatGPT or things like that is that here you're actually able to use the notebook as context. So that includes the markdown cells, but it also includes explicitly telling the AI to use information about the tables or data frames in your notebook session and to use that as context. So to demonstrate how this works, let's make a query. In this case, it actually used a SQL query, but we can try to force it to use ADA polars. Now you can, to make it more seamless, you can go into the settings here and explicitly try and force it to use certain capabilities, to use polars, to use pandas, to use ibis, and to do this or that. So this would be like the system prompt. And then you have options here of specifying which AI provider to use. For example, if you want to use Anthropic, you would specify the API key here. And then on this tab, you can specify which models to use for each provider. For in case of OpenAI, we have shown like every model is available. So the other built-in AI capability would be to generate code. So in this case, if you click here or down here, you get a code generation prompt. So for example, let's try this. I guess that seems correct. So these are kind of familiar features, but the really useful thing here is that it's able to take advantage of the notebook as context, and you are explicitly able to say, okay, use information from this data frame or DuckDB table. Before we wrap up, we have included some AI exercises here. This is just encourage you to look into the documentation of how to set up an AI provider, if you can get an API key for OpenAI, Anthropic, or Gemini or whatever, and then to test it out. It's a super convenient feature. It's really an AI powered or AI native editor, so that's something I encourage you to do. To enable this, you will get the ability to create additional columns. So you can here on the left hand side have an additional column, for example, for creating your work notes. So I did this, you did this, and so on. But then you can actually create even more columns. So you did this, and then you can say, if you go down to our visualizations, we need to do, see if I can manage to drag this. No. Oh, wrong button. I want to, here we go. I want to drag this up here so you can have, your visualization be contained in one column. You can have your notes in one column. And this could be a very convenient way to organize your investigation notebooks, especially if you have one of these ultra wide displays. And with that, we have shown enough of the Marimo capabilities to be able to do useful memory forensics. So let's proceed to the next notebook.